weekly paper 14. Yes, it says a particle P is projected from a point O vertically upward under the gravity with velocity u. Okay. This from a point O on the ground, particle P is projected with initial velocity u upwards. Right. So the particle P is now moving under gravity upwards like this, right? Okay. This is at t equals 0. Right, after time t, another particle q is projected with same velocity u upwards from the same point O. Right. So then, after time t, suppose the p is here. That is at time t. At that moment, q is projected from the same point O. Right. The particle is q. It is projected from the same point O with initial velocity u vertically upwards. This is at t equals t. So at t equals t, suppose the particle p is here, particle q is now here. T equals t, moment only, particle q is projected vertically upwards. Okay. Now you know this particle p is coming to its maximum height. I'll take the particle p coming to maximum height. This is the maximum height of particle p. That occasion, the velocity 0. Right? Velocity is 0. Right. I'll take this instant as the second instant. Right? Second instant. That means first instant is when the particle p reaches to this height, time is t. That moment only particle q is projected. So therefore, instant first instant is 1. At time t equals t. At time t equals t, first instant q is projected upwards, p is here. Second instant I take the moment particle p comes to the maximum height. Right, I will take when this p comes to the maximum height, that p took as the second instant, no? Alright. Then I will take q is somewhere here. Right? Q is somewhere here, second moment. Right. So then when q is here, now p is at the maximum height. Okay. Now, once the second instant happens, q has moved upwards this height. At the same moment, this p is at the maximum height. Then what happens is, p begins to move downwards along the same line. So I will draw that we are here. Then this is the moment p begins to move downward with initial velocity 0. Right. Okay. Now this way p comes downward, q moves upwards. A certain moment, you can see they will meet on their paths while p moving downwards and q moving upwards. I'll take that moment as third moment of both. Okay. Right. So then we can see, when I speak the story, from the moment q is projected upwards, right? Right. After projecting q, just before they meet, right, from the instant q has been projected. From that instant only I am talking now. From the instant Q has been projected, the height ascended by Q just before P and Q meet, and the height descended, right, from the maximum height, the particle P. This height and this height, if I take H1 and H2 like this, this H1 plus H2, you can see, is equal to the maximum height ascended by what? Particle P. This is equal to maximum height of P. You can see by this diagram that. Understood? Okay. So therefore, when we talk from the instant Q has been projected until they meet, the height ascended by Q plus the height descended by P from the maximum height. The total is equal to maximum height ascended by particle P. By this you can understand this. Okay. Right. So then we can draw the VT graph for the situation. The VT graph will be coming like this. This is the time axis. Right here, the first particle U or P is projected with velocity U. This way its VT graph we can see. Okay, right. Right, okay. After time t, we are not given exact value for the time t. I will take in generally this as our time t. At this moment only, the particle Q is projected vertically upwards from the same point on the ground. So its VT graph I suppose to draw like this. This way. The velocity is u. Now you can see before the particle Q reaches the maximum height, the P and Q particles both meet. So the VT graph of Q should not reach the time axis. Reason? When it reaches time axis mean velocity 0. 0 velocity occurs at the maximum height. Since P and Q meet before reaching the particle Q to maximum height, I'll take a time point somewhere here. The moment they meet, like this. Then this is the VT graph of Q, and this is the VT graph of P. Let us take this angle as tan theta. You know tan theta should be the retardation. The same angle here we should have, because Q also moving under gravity, therefore tan theta should be G. Right? Okay. Then upwards motion, it is a retardation. Downward motion of P, it is an acceleration. Okay. Now, I'll take this area like this. O, here C. Let us take this as A point A here. All right. This is taken as H in my diagram. This is B, E, F, G, and this is D. Right? We told the people that we are going to take this equation from the instant Q has been projected upwards. That means this is the moment particle Q is projected. This is the moment they meet. From this time to this time only, the discussion now we do, because our important equation to take the answer is this. Now you can see there, the height ascended by Q just before they meet is given by H1. That H1 height is given by, from this to right only we take the VT graph of Q. Then under this VT graph of Q, the covered area going to be C, D, E, F. Therefore, this H1, right, height is given by the area C, D, E, F. C, D, E, F area. This H2 height means the height descended by particle P from its maximum position. That is given by B, G, F. B, G, F area. Then you can see C, D, E, F area is H1 plus B, F, G area is the H2. That total should be equal to the maximum height attained by the particle P. That maximum height attained by the particle P is given by O, A, B area. So, from there we can start the discussion now. Okay? Then we can write. First of all, I'll take this velocity I need. I'll take this velocity as W and this velocity as V. This is theta. Then we can write by the diagram, tan theta. U is the full height from here to here, W. This is U minus W. Right? Divided by, this is T. Tan theta is G, U minus W over T. By this you can subject W, U minus GT. Like this, W is okay. Now we can write the relation CDEF area that is this. That area is given by H1 in that diagram, and BFG area. BFG area. CDEF area plus BFG area. The total should be equal to OAB area. OAB area. But you know, the left hand side total area going to be here CDEF. That means this trapezium plus this part is the total area. You can see this HBC, this area available in that. For the right hand side, OAB area also containing OAB, that also containing this HBC area. This HBC area is common for both left and right. So therefore, in the left and right, this HBC area, right, we can cancel down. That is removing common area from both sides. We remove common area from both sides, right? Removing common area from both sides. Right. In the left hand side, this whole trapezium plus this triangle. That means we get this trapezium and this part. From that we remove this part. Then we get only this part plus this. Right? That means HDEG. We get, once you remove this common area from both sides. In the left hand side we get HDEG. HDEG area is equal to, from the OAB area, if you remove this part, we get OAHC. OAHC. This way we get. Okay. You can see this HDEG is a parallelogram. Reason, this side is vertical, this side is vertical, parallel. HG and DE, parallel. Therefore, it's a parallelogram. The area of a parallelogram, you can write what? One side multiplied by perpendicular distance between that side and its parallel side. Right, this is the DH. DH. So, you notice this W is U minus GT. Then the height from here to here going to be, from the whole height U, subtract W. When you take W to this side, we get U minus W. Take this to right hand side, GT. Therefore, this is GT. The perpendicular height is CF. Then this left hand side, we can write GT into CF. OAHC area, I can write, it is a trapezium. This side, sum of the parallel sides into perpendicular height divided by 2. All right. So then OAHC we can write half U is this height, other height is U minus GT, sum of the parallel sides into perpendicular height. This way we get. Right. By this, we can cancel down this T. By cancelling this T, we get the time CF, which subject is time CF. CF, when you subject, bring here 1 over 2G. To U minus GT, bring this 2G inside, 2 and 2 you can cancel down, U over G minus T over 2. Also bring inside this. This is the time CF. The time CF is the time taken by the particle Q to meet particle P. Okay. In other words, after the projection of the particle Q, the time takes to meet them. Okay. Now the first question asking, when the particles meet, the speeds of them are equal. All right. Now we need to find the V, and we need to find this V dash, suppose. We need to show V and V dash equal. I can now write this way. This V I can write applying tan theta ratio. Tan theta means this side divided by this side. This side going to be whole height is U from here to here V. Then tan theta whole height U from here to here V, U minus V divided by CF time. Okay, then tan theta G, bring the CF to left hand side, U minus V, bring this V to left hand side, U minus G times CF. CF time is this. Okay, U by G minus G by 2. Okay, then we can simplify this. Remove the bracket. This and this you can cancel down. Then we get U plus GT by 2. This 2 you can cancel down. V equals GT by 2. Okay. That means when the particle Q meets the particle P, the velocity is GT by 2. Asking to show the velocity of P also GT by 2. That you can very easily do. We notice this DH. This DH is GT. But that DH and this EG are equal because this is a parallelogram of the sides are equal. So therefore, we can write this EG from here to here, that's the velocity, is equal to GT, this. But EG is, one is this height, other one is this height. FV plus FG, GT. F is this V here, GT by 2. Put here GT by 2 plus FG equals GT. FG takes right hand side, we get GT by 2. Now what can you say? When the two particles P and Q meet, their velocities GT by 2 equal and size is GT by 2. Then you can give the first two answers by this. Third one asking the two particles meet after time this much from the instant of projection of the particle P. That means the time asking from O to F. OF time asking. OF time we can write OC time plus CF time. OC time plus CF time. OC time plus CF time. Right. I write that here. We need that OF time. OF time, it's OC plus CF. OC time is T. CF time we found, right? That CF time U by G minus T by 2. This is really U by G T minus T by 2, T by 2. Right. Third answer is this. Fourth answer asking OA. We are given the two particles, they meet at the point A. This is the point A. O is here on the ground. Then we need to find this H1. H1. H1 means, people, we need to find this C, D, E, F area. C, D, E, F area only we need to find, right? The height ascended by particle Q just before they meet. Okay, right. CDEF area. It is half sum of the parallel sides. One is this U, other one is this. If V, it's V. V we found GT by 2. Right? Half sum of the parallel sides into perpendicular height means CF. CF is this. U by G minus T by 2. Okay. Right. This is really, okay, I can write this 2U plus GT, taking the common denominator here and bring this inside 4. Here 2G, common denominator, 2U minus GT. Now simplify this. Here G come in, 2U, 4U squared. Here, right here, A plus B, A minus B form, no? 4U squared minus G squared, T squared, divided by 8G, right? Okay. This way we can complete that question. Right. That is how we take the first answer. Right? Okay. Okay, we'll move to the second one. There you are given a vector question. OACB is a parallelogram. OACB is a parallelogram. D is a point on OA such that ODDA 2:1. E is the midpoint of OB. The line CE and BD, CE and BD meet at F. If it is given that OA equals simple A and OB equals simple B, find BD and CE. Right, okay. This way, let us take our parallelogram. O, A, C, B. We are given this OA vector as simple A, OB vector as simple B. D is a point on OA, ratio 2:1 like this. E is the midpoint of OB this way, right? Is to I equal. Ratio 1:1. BD, we can join like this. And CE. Right. They meet at the point F. Okay, ask him to write. Find BD and CE. BD, vector asking to write. B D vector you can write B O plus O D. B O, OB vector is B, therefore B O vector is minus B. OD vector we can write as a part of simple A vector. Simple A vector we divide by 3 and multiply by 2. Then we get BD vector, right? 2A minus 3B by 3. And next one is the asking CE vector. CE vector. CE vector you can write by using the triangle law of vector addition. CE vector this, no? BD vector this. CE vector I can write CB plus BE. CB plus BE. CB plus BE. C to B vector is the negative vector of O to A. Then CB vector is minus A. BE is the midpoint of BO. Then it's minus B by 2. Minus B divided by 2. Then we get CE vector. Taking minus sign out. 2A plus B by 2. Like this. Right. Now, next one asking, we are given FE equals lambda CE. FE vector lambda times CE. And another vector given BF. BF is mu BD. Right. BF given, FE given. Here to here the vector given, here to here the vector given. Then asking to find the values of lambda and mu. Right. Then we can write here BF vector, BF vector plus FE vector equals BE vector. Right. BF vector is mu BD. FE vector given as lambda CE. BE vector means minus B by 2. Right. Okay. Now we can substitute for mu BD vector is this 2A minus 3B by 3 lambda times CE vector minus 2A plus B by 2 is equal to minus B by 2. Now this A and B are two non-zero, non-parallel vectors, no? Then we can equate left and right coefficients of vector simple A and vector simple B. Here, remove the bracket, 2 mu by 3, I am going to equate the coefficient of A, 2 mu by 3. And here, this 2 and this 2 we can cancel down, minus lambda. A, coefficient is minus lambda. Right hand side, no A term, therefore, first one we get this way. Then this gives us lambda taken this side equals 2 mu by 3. And equating B coefficients, this and this we can cancel down, minus mu. And here, this and this we can multiply minus lambda by 2. Oh, there it's minus half. Okay, now for the place of this lambda, I can put this, right? Minus mu minus, here we have lambda by 2 now. Bring this 2 here, then we get lambda by 2 is equal to mu by 3 equals minus half. Minus signs you can cancel down both sides. Then we get left hand side 4 mu by 3 is equal to half. Mu is really 3 over 8. Then we can find lambda. Lambda means 2 over 3 mu. 3 over 8. This and this you can cancel down. Lambda is 1 upon 4. This is lambda mu we can write. Now asking next one. BD and CE are perpendicular to each other. BD and CE. BD vector is this. Second is CE vector. Are perpendicular. This is CE vector. BD vector and CE vector. Here 90. BD vector and CE vector perpendicular. Right. You know when two vectors are perpendicular, right? The dot product of the two vectors is equal to 0. Right. So then we can write BD vector dot CE vector is equal to 0. A BD vector 2a by 3 minus 3b by 3, right? So we write like this. Dot CE vector minus 2a plus b by 2. This dot product should be equal to 0. 3 and 2, 6 denominator. 3a minus sign we can ignore. We can take 2a minus 3b dot 2a plus b should be equal to 0. Then here we get 2 and 2, 4. A dot A, right, plus 2 A dot B and next one minus 6 B dot A. B dot A same as A dot B, we know that, minus plus minus 3 times B dot B is equal to 0. You know A dot A mean people mod A squared. Mod A squared, right? For mod A squared. 2a dot b minus 6a dot b means minus 4a dot b. And here minus 3 b dot b is mod b squared is equal to 0. Then we get that answer too. Right. Now asking, hence, if OACB is a rhombus, if OACB is a rhombus, OACB is a rhombus, you know in a rhombus, the adjacent sides equal in length. So then we can take that answer by this last result. The last result we have to use to take the next two answers. For mod A squared minus 4 A dot B minus mod B squared equals 0, no? Right. First part asking OACB is a rhombus. When OACB is a rhombus, this OA length and OB length are equal. OA length means mod A because OA is represented by the vector simple A. Then OA length going to be simple A vector modulus, right? So then in the first case, when OA CB is a rhombus, mod A and mod B being equal, then in this we can put that for mod A equals, for A dot B we can write mod A mod B cos theta. What is this theta? Between the two vectors A and B, the angle, that is this angle, minus 3 mod B means mod A, because mod B and mod A are equal, no? This way. Then here 4 mod A squared minus 3 mod A squared is mod A squared. 4 mod A mod B being equal, no? Here also we can put this 0. This we can cancel on with this. Then 1 equals 4 cos theta. Theta equals cos inverse 1 upon 4. That we can take first. OACB is a rectangle, second one. When OACB is a rectangle, when OACB is a rectangle, people, when OACB is a rectangle, this angle is 90. The angle between OA and OB is 90. That means the simple A vector and the simple B vector perpendicular. When two vectors are perpendicular, dot product is 0. When OACB is a rectangle, A dot B becomes 0. Correct, no? Here 90, this angle is 90. A vector and B vector perpendicular. Dot product of two perpendicular vectors is 0. A dot B is 0. A dot B 0 means this is 0. Then we can put 4 mod A squared, this is now 0, equals, bring this right hand side, 3 mod B squared. Then take the square root on both sides, mod A root 3 by 2 mod B is the answer. Right. Right. Next one. Question number 3. Okay, number 3. A uniform rod of weight W and length 2A has its one end A resting on the corner of a smooth horizontal floor and a smooth vertical wall. The other end B is supported by a smooth peg and the rod is in equilibrium, making an angle theta with the horizontal. If the reaction at the end B is W upon 2 root 2, show that theta 45. Find the horizontal and vertical components of the reaction at A. What is the distance of the point at which the reactions at A and B meet from the wall? All right, so really good question. Right, so this way we have the rod, so uniform rod. Right, end A is here. There's a peg here. By the peg, a normal reaction coming this way, perpendicular rod. Its size is given W over 2 root 2. That is perpendicular to the rod. Suppose rod AB, our weight here at the midpoint acting W. Then the weight 10, this reaction they meet somewhere here, suppose. You see? They meet here. Right? Okay. They meet here. Then another one force acting on the rod, that is at the end A, the reaction. Finally, the rod is in equilibrium under the action of three forces. We have learned when any object is in equilibrium under the action of three forces, they must meet at a point. So therefore, since that reaction and this weight W, they really meet at that point, the reaction here should also be passing through that point. Like this. You see, right? Right. So this is R. So I am going to consider for this R there are two components. I take that as X. The vertical component as Y. This way I take the two components of R. We are given this angle as theta. Let us take the length of the rod as 2A. Now for the equilibrium, we can take moment around A, right? We will take moment around A in anticlockwise. There the force is W over 2 root 2. The perpendicular distance is 2A is equal to W times, right? When you produce like this, the line of action of W is the required length. From here to here it's A, this is theta, this is A cos theta. A and A you can cancel down. W and W can cancel down. 2 and 2 you can cancel down. We have cos theta 1 over root 2. Theta equals pi by 4. Right. Secondly, asking find the horizontal and vertical components of reaction at A R. Now for the equilibrium of the rod, we will resolve horizontally. Then X. Here, when you draw horizontal line, this is 45 because this theta we found to be 45. Then this also 45. Then W over 2 root 2 we get cos 45. X equals W over 2 root 2 cos 45. Cos 45 is 1 over root 2. This gives us W over 4x. Resolving upwards, we can find y. Y going to be here vertical component of this, and here y upwards is equal to W downwards. So therefore, y is equal to W minus W over 2 root 2 again cos 45 or sin 45, both are correct because this angle is 45. No, this is 45, therefore this is 45. When you draw vertical here, this is also 45. That's why. Then y, right? W over here 4. No, 1 over root 2, root 2, root 2, 1 over 4. Then this is nothing but 3w over 4. Right. Horizontal, vertical, the components we found. What is the distance of the point at which the reactions at A and B meet? From the wall. This is the point they meet. The wall is this, along this y when we draw vertical line, that is the wall. This is the wall really. The distance this is asking. Right? That distance is same as the distance this. Okay? The distance is well obvious. Here to here it's A, this is 45, therefore this is A cos 45. That means A over root 2. That way you can complete that question too. Right. The question number 4. Three forces this way, Pi, 2Pj, 2Pi minus Pj, and API plus BPJ act at the points on OXY plane with Poisson vectors, this. Okay. We'll do that too. X-axis into vector is I, y-axis into vector is j, here O. Right. Now, first force is Pi plus 2Pj acts at the point I plus j. The point with the Poisson vector I plus j mean people, I coefficient is 1, j coefficient also 1. Then 1 comma 1 is the point. Therefore, the force first given Pi plus 2Pj, Pi plus 2Pj acts at the point this. Let's see what are the two components, horizontally and vertically, of this given force in the vector form. Pi, positive I here we have. Positive I direction is this. That direction the force is P. Positive J here we have. That is this direction. 2P. Right. So that is how we identify the two components and the point. Okay, then one point. Here, 1 comma 1 point, the force is P, here 2P. Secondly, minus I minus 3J, minus I minus 3J. Minus I minus 3J is the point. It is minus 1 minus 3. Minus 1 minus 3. This is that point. Here the force is 2Pi minus Pj. This direction 2P. This direction it is P. The point is here, coordinates minus 1 minus 3. The next force is acting at minus 2I plus J. Minus 2 here, here. Minus 2 plus 1 is that point. And the two forces acting AP, BP. I'll take this A times P, B times P like this. These are the forces. Right. Now question gives, if this system of forces reduces to a couple, find the constants A and B. When a system of forces reduces to a couple, you know it has no resultant force. That means when you resolve horizontally, x should be 0. When you resolve vertically, y should be 0. Right? That is because of given it is reduces to couple x0 and y0. X means resolve the horizontal. That means algebraic sum of the horizontal components. AP, P and 2P. Right? AP, P and 2P should be 0. AP plus P plus 2P equals 0. P you can cancel down. Here we have 1, then A is minus 3. Y0 mean 2P plus BP minus P should be 0. P you can cancel down. B is minus 1. Right. Now, ask him to find the moments of the couple. You know, moment of a couple is a fixed value around any point on the plane of the forces. So therefore, this time I can take the moment of this couple the point O. I'm going to take the moment around O. I take moment around O in anticlockwise sense. Then that 2P around O will give anticlockwise moment. To that 2P line, the perpendicular distance from this O is this. That is the x coordinate of this point 1. Then 2P into 2P. And that P around O gives clockwise moment, minus. Okay. By this AP around O clockwise, BP also clockwise. Then minus AP, the height is the y coordinate, it's 1. BP around O gives clockwise moment, the distance, this length, 2. And around O by this, right, 2P. Around O is 2P. It is anticlockwise moment, 2P. This is y coordinate of this 3. By this P around O, this way, anticlockwise moment, P into this length, x coordinate 1. Now we can simplify here. 2P minus P, here P. Here A is minus 3. Then here we get plus 3P. B minus 1. Then here plus 2P. This is 6P. There P. Then we get 13P. Is the moment with the sense anticlockwise of this couple. That is how we do that question. Right.